turning projects, which I did in collaboration with the Plumier Foundation. I was one of their interns there, along with Jeffrey, who's here today. I think he talked yesterday, and Kelsey Watson, who was from New York, and he's the other intern. But I had the opportunity to do that, and I'll talk to you today about some of my adventures there, things I learned along the way, things that went well, things that didn't, and some of the projects in kind of mixed media, collaborating between metalworking and woodworking. So let's see what slide works. What do I have to point it to you? Anyway, a little bit about me. I teach machining, currently teach machining, metrology, which is measuring, as well as some metallurgy at the Pennsylvania College of Technology, which is part of Penn State. It's in Williamsport, Pennsylvania. I've been there a couple of years, about my third year there. Before that, I worked for the National Air and Space Museum, Washington, D.C. I was an objects conservator there, worked on a lot of historic aircraft, as well as engines, all kinds of other things. Originally, I was a tool and die maker. So I'm really a metals guy. I'm really a metal worker. That's my background. I've been interested in Rose engines. They've piqued my interest quite a while ago, maybe, I don't know, at least 10 years ago. They kind of struck my fancy because I love machines, and the ingenuity in them, and the fact that has a headstock that rocks. I'm not used to that. I'm used to metal lathes with headstocks as rigid as possible. So really it piqued my interest. And my experience until going to Plumier was more with guilloche, with metalworking, as far as Rose engines go. So my interest in exploring wood was that to be able to make a three-dimensional object using the Rose engine, rather than a flat or slightly, curved pattern with guilloche, they're actually making a whole object, a whole box or a whole shape. Really, that's what kind of turned me on about it. And I had the opportunity. I was really excited about Plumier, so I'll get more into in a minute. And so, what else can I tell you here? So I've had a lot of interest in metal, silversmithing, which I combine with this sort of traditional English silversmithing techniques from hinge making and box making. I've always been into blacksmithing, traditional Japanese metalwork, stuff that was used on samurai sword fittings, as well as vases and that type of thing. And I combine some of that work with the wood, which I'll talk about today, as well as artistic and traditional locksmithing, always into that too. So I'm really a metals guy, really a machinist, putting my hand at woodworking and ornamental turning in the woodworking context. So let's move on to the next slide. So, like I said, I was one of 3 interns that got given a stipend to visit Port Chester and work in the Plumier studio. Many of you are familiar with Plumier, but it was founded by Bill Ruprecht, who over probably a 30-year career in the high-end art market, and I believe at Sotheby's. He always was interested in ornamental turning. He purchased half a dozen or more premier machines, which he put in storage for many decades, with the hope of making them no longer museum pieces, but working machines that people could come and use and learn from. Fantastic opportunity. So I've known Dave Lindo a long time. He was hired to help Bill set this up and run it. I'd worked on and off with Dave over the years. When I had time, I've helped him make parts for the Lindo machines, made lathes, etc. But exciting, and I wanted an opportunity to do that. I wanted an opportunity to, hey, I get to handle and actually be in the same room as all these classic machines. I thought that was an amazing idea. So happy to apply, and I was accepted. And the past, I guess, 2-3 years, I've been going when I had time to work. So really why they picked me was because I have a metalworking background. I was really interested in combining metalworking with functional elements. So hinged lids, that's something I'll show you, hinged parts. To add some more dynamic elements to woodworking projects or ornamentally turned boxes. Like I said, the other thing I wanted to do was try to inlet the metal panel into the top. You can see that on my cover slide, and that's kind of in the style of the Japanese work, which I kind of like as well. So I'm kind of bringing in a lot of my different interests and trying to make something happen. Mechanical elements such as hinges, latches, springs, that type of thing, as well as mixed media combined with OT. And what Plumier I believe is trying to do right now is to bring different disciplines together wood turners, with jewelers, with glass workers, with metalsmiths. So I think really ornamental turning, I think, is going to reach another level, I think, as it's being combined with other disciplines. I think crossing over with other disciplines, I think, is a good thing for the future of it. At any rate, that's the internship. Great opportunity. Really happy to be involved in Port Chester for their initial startup. It's exciting that they're going to move to Pennsylvania for a permanent location, and which will be great. Hope everybody will have a chance to visit there once they're set up. So yeah, so working here. Okay, so what I've started with at Plumier, I'm kind of new to cutting wood on Rose engines. I'm used to metal lathes. I've had thousands of hours in the industry cutting steels and all kinds of metal. New to wood. So the biggest thing for me was to get used to, man, you can take a really heavy depth of cut with wood. So install the machine out. I'm used to metal, you got to take a pretty light cut and take it fairly easy. But here you can really rip the material off. So that took a little getting used to. I was used to being a little bit bashful with it, really, when really you can rip the material off. And the tool pressure really is minimal. That's the one thing I really learned with ornamental turning coming from metal, is the tool pressure is almost negligible, because if metal, there's a lot of resistance between that cutting tool and the metal you're cutting. So the work will deflect, the tool will deflect. But here it's very, very minimal. So that was kind of a nice thing to learn. That was kind of a neat thing, neat bonus, really. But so when I went there first, they kind of run you through, some basics. I did a bunch of bottle stoppers. I used the different cutting frames, the eccentric cutting frame, did some spheres with that. I did used the different vertical, horizontals. A lot of the stuff Rich talked about earlier, we went through. And we used some other stuff like the reciprocator on the Holzapfel to do sort of sinusoidal waves on the side of parts, and just a little introduction to all the machines. So that was pretty good to get my sense of the how this all works. So again, one of my ideas to try there was, okay, I want to try to combine, I want to combine, make some hinges. So the box leads will hinge. That's something I think David was interested in looking at, and something I was too. And I had some silversmithing courses here in England where I got to make some basically traditional pill cases or card cases. And it's the same kind of technique used for maybe watch cases too. So I was trying to combine that with some wood. So what I wanted to do first was try an elliptical box. That might be a neat idea. So I think, how am I going to make the metal shape, the metal bands, to make this, the hinge system out of metal in elliptical shape? So I thought, well, jewelers use tapered mandrels to shape the ring. They're, if you want to, they're trying to make a wedding band or something, they'll hammer that on a mandrel to get it the right size. So I thought, well, I could use that technique. Well, blacksmiths do too, they had the big cone mandrels to make wagon tires and that type of thing. So why not make a ornamentally turned wooden taper that could help me form the elliptical shape for the box? I thought that'd be a neat way to get started. Cut some wood, and get used to the machine. So that was the first thing I kind of got into doing. So we have a Lindo machine, very much like this one, and it has the I think that does have the curvilinear slide on it, which is powered, which is nice. So I can run a belt off of that, so I can automatically cut the shape. I don't have to sit there and crank that. The machine itself, like this one, has a motor to drive the spindle, and you can see here the curvilinear slides here. And what I did is I actually got a protractor. So what angle do I want the taper to be? So I got a protractor and just set the slide at an angle off the table. So rather than setting it so it's in line with the spindle, I set it to, I forget what, maybe 10 degrees, let's say. Set that slide. So when that slide's powered along, it would cut a taper effectively. So that's what I'm doing here. I think I'm using the horizontal cutting frame. I think it's just pear wood. Again, this is just a tool I'm making, mandrel to hammer a piece of metal on, something we had in stock. So that's held in the chuck. And a couple ways we could do the ellipse. We could have set up the elliptical chuck. That was an option. But there were some elliptical cams, I think, that come with Windows set. A couple different ones that they had in stock. And we thought, David and I thought, well, that probably worked fine. Nice thing there is each cam, there's a couple different ones with different amplitudes, basically. So I thought, well, you had that set cam, you could make you know, the taper to match, and then everything be consistent. All you'd have to do is have the cam, and then you cut your box from it. We thought that was a great idea. See how good of an idea it actually ended up being. So made some tapered elliptical forms, which I forgot. I made a couple of them, a larger one and a smaller one that would match up. I was going to bring them along, which I didn't. And the idea was to use the standard elliptical cam to provide the taper rather than the elliptical chuck. So I'm using the powered cross slide here, the powered curvilinear, and the headstock's rocking, and I'm cutting it. So thought everything was great. Thought everything was great. Oops. So can I go back? There we go. So anyway, so that's what I did. I made the elliptical forming mandrels, and then what I did here was to I ran some brass wire through a rolling mill that had a profile on it. So basically, first thing I did was to make basically a brass ring that was elliptical, 2 of them. Then I fit a piece of brass into that, soldered that in place. As you can see that, so it ends up being like a little tray. Now, if you were making a little card case or a little pill case, you would actually have the outside of the case, the flat part of the metal, and then the opening on the inside, like a little box. But here what I did is I actually kind of turned it inside out, and I said, well, let's put the flat faces on the inside and the recesses on the outside, and then on the recesses, you're actually going to inlet the wood. So this was just an experiment, and this was made to match that tapered mandrel I showed you. So it was made out of a ring of brass wire that was rolled to a profile, and then soldered to a sheet, and then the hinge knuckles were all lined up. I think this one there are 5, and 3 of them are on one, 2 of them are on the other, and they're all soldered in place, and there's a hinge pin. So this is kind of a prototype. And my idea was, okay, great. I had that standard mandrel. Now all I got to do is use that cam and machine a piece of wood to fit that, and everything will be great. Well, it turns out, and this is the first adventure I had there and the first lesson learned, apparently that doesn't work. Apparently you don't get an ellipse, you get a Cassini curve, which I'd never heard of before after we did some thinking. But apparently, and I can see it on the smaller one, you actually get this sort of peanut shape. When you use a cam like that, it will cut an ellipse at that size, but if you reduce it, when your cutter further towards center, like Rich showed us earlier, that pattern gets contracted, and this gets crazy. It actually goes from sort of an ellipse to an oval, and then it gets kind of peanut shaped, and then it goes into this sort of, I don't know what you want to call it, two eyeballs looking at us here. Really weird shape, but not what I was after, but learned a lot. It was pretty fun. So the Cassini curve was interesting. Guess you could make that shape if you wanted to. But I think that the idea, is sound, turning a taper that's off a given rosette to then form metal to match it. I think that will work. It's just to use an elliptical chuck now to cut this shape is not possible. So anyway, learned a lot, had fun, did some prototyping. So I moved on to something else. Let's see what's next. So this time I decided I like the kind of puffy square, the 4-lobed square shape. I found that to be an appealing shape. I kind of wanted to explore that. One of the reasons why was, for all the hours I spent running the machine, making those ellipses, there was a square rosette right there the whole time, going around and around. I must have after me staring at it for several hours or days, something finally stuck. So it was a pleasant shape, and again, it reminiscent of Japanese work. You see these shapes in Japanese work, or these sort of cushion shapes. So I thought, that's it. I want to try that. I'm going to try to build a hinge. I've proven that the hinge is possible. I want to try to build a box with that shape instead. So this time, rather than building a forming mandrel, I said, well, I figured, well, I can probably fabricate it by, if I know the radius of that curvature of that shape, if that's a known radius, and I was able to figure that out by knowing the amplitude and contracting it to the size I wanted. I figured, okay, well, rather than making a forming mandrel, I'll just fabricate basically a bezel like a jeweler would for setting in stone. So what I did was once I knew the radius, I got a strip of brass, ran it through a slip roll forming machine, which will roll sheet metal and bands to a specific radius. So I just took a piece of brass, rolled it to that radius I wanted. So the entire piece was curved. I cut the corners, I notched the corners and bent this up into this square shape, soldered them all, and then soldered that to a back plate. You can see here where I have it wired together to be soldered. So I'm using this is a jeweler's brass, like a gilding metal, so it's a high copper content brass, and it's pretty soft, but it solders well and it finishes nice. It has a nice rich look when it's done. Wasn't brave enough to use silver at this point. And I was certainly not going to use gold. Maybe someday, probably not. So any rate, so we got that on there. The idea was to silver solder this together. So silver soldering is a high temperature brazing process, basically. And there's different solders you can use that have different melting points. Generally, I want to start using the highest melting point solder first, and then I can go subsequently later with lower melting point solder, so I don't melt what I already did. So all this is done with what they call hard solder, where the high melting point, as much as I can with that. So the first step was to build this bezel, basically, and then solder it to the back plate. And see, I have it wired together with some tie wire. And you can see my drawing here. Basically, I figured out, well, how big do I want the thing to be? And what radius do I want for the edge? And then the roll forming machine's there, which I use to do that. So here we go. So a lot of pictures here, but so basically I made kind of what I like to think of as an ice cream sandwich. So if you imagine that bezel before soldered to that plate, if you have a flat plate, you have that bezel soldered to it. And then I soldered another one on top of that. So it's like a little ice cream sandwich. You have one top piece, you have that band, so it's a little compartment in there. And then you have a bottom on it. So have all that. Now, if I just slice it in half, then I have two of them. So you can see up there, I have it on the milling machine with a big slitting saw, big high-speed steel saw blade, very thin. And I just slice it in half, just like a sandwich, just cutting it right in half, splitting it. And then what I did was to trim it. The jeweler sometimes will trim it with a little saw or file. I used a sheet metal notcher to do that, which works quite well because it allows you to trim the edge. So basically, I'm trimming this waste material here, this sort of excess, basically the biscuit part of the ice cream sandwich overhangs the center. Trim all that down, you get a pretty clean little tray. So basically I have two of these little trays now, which then I can build into my hinge. So then what I did is to file in a groove to put in this tube. So I got a little brass tube, and I got a round edge file, filed that in. What that's going to give us is that's going to give us an area for the hinge to be. Okay, that's not the hinge itself, but it's the effectively where it's going to bear. And because this shape isn't flat, it's curved, so you need to add that extra metal to support the little hinge knuckles. And that's one reason why I use this shape as opposed to like a round box. A round box, you really don't have a lot of area to put a hinge. The hinge would have to be pretty narrow. You have to put some big chunk of metal on there to extend it. But that's why I went with this shape, because it's actually relatively straight, and it will give you that room to do that. So that's basically put in place with wire, then it's soldered, and then it's split, and then I can go in and put the hinge knuckles in. This is a pain in the butt to do. It's a pain in the butt, but it's fun. If you take your time with it and wire them on, it does work out. So for this one, I put in I used an even number of knuckles for the hinge. Before I used an odd number, so there were 3 on one side and 2 on the other, so a total of 5. And if you want your hinge to be sprung, which I did with this, you need an even number. I'll get more into that later. So you need an even number of them. And so here's an opportunity where I wanted to use a lower temperature solder, because if I went in here and soldered this, it would probably melt the solder I already had applied. So I went with a medium solder in this case, which has a lower melting point. So a lot of setup here, a lot of soldering, but overall a fun project.
Question.
Yeah, what's up?
The tube and it's wired on top, is that your knuckle material?
No, that ends up being a bearer material. That ends up like being a trough that the knuckles fit into. If you look here at this, see how there's that trough there, that sort of groove? See it? Right there? That's actually this after it's soldered in, and then it's cut down. It's an extra step. I think I did it because I think it was a little. It makes for a little more area for it. You don't have to, but I think it was helpful to do that. But good question though. A little confusing. Yeah.
So is it a soldering iron or a flame?
Flame. Yeah, you need a fair amount of heat here. I forget what the melting point is of this stuff, but it's probably 1200 degrees Fahrenheit, something like that, maybe even hotter. So it's quite a large flame. I used a jeweler saw, and there are tools available for jewelers to cut hinge knuckles and that are available, which I used for this. Yep. So you need them to be ends need to be square on it. Obviously, you don't want the ends to be uneven. You can certainly use a little lathe, would work fine. In the past, I've used a little drill press, just bring it down on a file or a piece of emery cloth to do it. So,
When you soldered that,
yeah,
what kind of wire did you use to keep that wire from soldering and do that?
good question. That's low carbon steel wire, like iron binding wire. I forget what I did here, but you can put yellow ochre on there or whiteout even. It'll help it keep it from sticking. Honestly, it did stick, and you got to peel it off after. At a couple spots, it did stick. You just file it down. It happens. But you can put yellow ochre on, which is like a earth pigment basically, which it's dirt basically. So it keeps it. Your soldering needs to be kept really clean. So if you add that, basically it will keep it from flowing because you're basically adding dirt to it effectively. So that I think I did do that. But at the end of the day, it's going to stick. You deal with it. You file it off, and move on. But really good question.
Okay, Daniel, I'm getting worried.
Okay.
What you're doing with this, but it seems
Okay.
like
We're going somewhere.
you're making it again.
Yep.
And now you're going to make a file.
Exactly. We're almost there.
It's not the opposite way.
Yeah, I did.
I don't know what I'm doing with now.
Yeah,
I know what I'm doing with wood.
and that's we'll get that because I ended up doing the hinge first, and then the box, and then I did the box and then the hinge later. I think it's a better way to go. So good question, good comment, Ernie. So there it is, pickled. I put it in acid to clean all the scale off and all the garbage, and that's basically done. You can see here where there are 3 knuckles on this. No, there's 2 knuckles on this one. No, there are 3 on each. There's an even number of knuckles on this one. 1, 2, 3, and 1, 2, 3. So it's all done, and it's ready, pretty much there. So that's it, prototyped with a polished up roughly hinge pin in there, and I did make a catch for it, little catch so you can push a little button and it'll open up, and that's a little push piece here, and the spring for that is here. So it's a little piece of spring wire, and then that button can go in and out. The 2 holes are for keeping it from when you're soldering it so it doesn't blow up, basically, to keep the air from expanding. But I drilled the holes so if you're heating the whole thing up, it would probably, once it's soldered, it would actually contract and probably crumple. And also to get the acid out of it when you're etching it. So those are just holes to let the air out of it when I'm heating it, and the acid when I'm etching it. So good question.
And
Yeah.
use uronic acid.
I use like a jeweler's pickle. I think it's like basically sulfuric. I think it's sodium bisulfate. Put it in a crock pot, heat it up. Yep, of course. Okay. Yeah, that works as well. So that's kind of the prototype. So pretty much brought it to this phase, and then this I moved between my dad's, I had tools at my dad's house, which is in northern Pennsylvania, northeast, and I was kind of traveling to and from Plumier, working on this at home, then going into Plumier, working on the next step. So I did a lot of, as David would say, forth and back for this project, but I did this at home and then brought it to Plumier. So let's move on to the next one. So we're back at Plumier now. So yes, I made the hinge first, and then went at the machine. So back to make the wood. So here we are on the Made lathe, much larger machine than this. And my idea was here to rough the box out with this puffy square shape, and then figure out how to fit that metal to it. So you can see here we have a horizontal cutting frame here, and then there's a curvilinear slide here, so I can follow that template. So to get the curve of that box, it's following the template that's clamped to the rail there. So it's African blackwood, and I'm cutting that. And I had to leave enough meat on the end because I'll have to go in later with an end mill to cut the recess to fit that metal band over. The rosette itself is way out here on the auxiliary rosette holder. A lot of the work we did on these was out here because this is a wonderful number of rosettes here, but always seems like the one you need to use isn't there, and it's a huge amount of work to take this apart. So we would usually just mount rosettes over here on the outboard. So that's where the puffy square rosette is, and it's rocking, and we're making the box. So pretty exciting for me to do this. It was really, really neat to get a chance to do that. And so that's the outside. Rough that in, and then got an end mill, and this is set up for the end with the end mill in the drilling frame. And basically I cut down basically this is actually a T rest. So the curvilinear slide is still in the orientation it actually set at 90 degrees. So you don't actually have to take the tool slide and turn it. You can leave it set up. So I was able to cut that profile around, which you can see here, to fit that. It turned out pretty close. A little bit of file work to get it to fit on, but it did work reasonably well. So I was able to cut that down till that fit on there, and I knew it'd be close because I did some paper tests before to get the extra curve I was going to make the metal too. And then I switched to the another cutting frame to cut out the inside of the box, which is here. And this is one, again, Rich talked about them earlier. This is the type that has a long tool bit in there. You kind of need that when you're reaching down into these deep pockets like that. So I had to stick the tool bit out pretty far. It's a single tooth bit to have it enough throw so it could actually do this shape. Because if you don't, the frame will actually bump into the internal shape of this cavity that you're making. So for these really deep pockets, you need to extend that out. So that was using the horizontal cutting frame to cut the inside of the shape. Next one. Do we have another slide? Okay, here we are again on the Made lathe with that horizontal. It's a universal cutting frame, it looks like, but it's set up as a horizontal. And again, it's in the T rest here. And I just running it straight in. I mean, it would be in the future, it'd be neat to run a curvilinear, so it would actually kind of hollow that shape out of the inside. But here I just went straight in with it. But really fun to use this machine. Really a lot of fun, really inspiring. But that's what I'm doing there. And you can see as this rocks, there's not a lot of clearance when this actually rocks back. So you need to have that tool pretty far out. So that's a single cutter. Yeah.
Consider using a drill with an end mill?
To carve that out?
Yeah.
I think you could. You could. Yeah.
Looks like a harder way to do it.
Yeah, that may be a good way to go. But this gives it a scooped out shape. I think a small end mill, if you wanted a straight sided box, that might be a good idea. Or rough it out with this and go in with that. So that's a good tip. But here I'm just holding it in the collet in the machine, and then almost that part's on its way. So let's see what I'm doing now. So a little bit of hand carving to finish out to make that box match with that metalwork I already made. So I didn't know if hand carving on a turn piece was a bad thing or it was a no-no. I don't know, but I ended up doing it, and it was a lot of fun to kind of combine the sort of geometric shapes from the ornamental turning with some hand work too. So what I did with the hand carving is I kind of blended the sides of the box up so they're nice and clean around the shape to match. Then I had to machine out an area for that little spring catch to go. I did that on a milling machine and then with some hand chisels. And again, combining metal with wood, I had to figure out, well, how do we hold them together? And I felt like screws were a good idea because I think I'm not a wood expert on wood, but I know it expands and contracts with moisture and humidity. And I think screws would be a little more forgiving than using adhesives or something, or really a press fit. And I wanted it to be rebuildable, if you will, so that you could take it apart in the future if you wanted to clean it or polish it or something. So I felt like screws were a good idea. At the time, I didn't know. I never really put screws into, machine screws into wood of this size. I thought, well, I'll just make some little brass inserts. So I did, and then I glued them in. You can see these holes here. I glued the brass inserts into those holes, and they were threaded. And other people I was working with at Plumier like, oh, Blackwood holds threads just fine. So maybe it was an extra step that I didn't need to take. And my second prototype, our second box, which is here, I decided I'll skip that step. And I did some tests, and really, this machine screw threads hold pretty well in Blackwood. I was pretty surprised. So I omitted that step. But basically, here I'm carving out for the catch, and then the holes are drilled for the screws to hold that brass shape on. Let's see here. So here I'm cutting the bottom. So I sawed it off. It was on one of these clarinet bells that are a really good source of wood. And each one has like a 1-inch diameter tenon on it to hold the collet. So here I had hand carved it, ornamentally turned it. It's still unfinished, but sawed it off, and then I put it the inside's machine. Again, a little nervous about holding it. I used a 4-jaw chuck here to hold it by the inside of the box. And Blackwood's pretty strong, as I've learned to appreciate, but I got nervous and I got some wire around it so maybe it wouldn't split. But so I'm holding it on the inside of the wood with the jaws opening, basically. And then I use the cutting frame just to trim the bottom, kind of face it off. And that's pretty much it for the bottom of the box, or the body of it. So we'll take a little diversion here, take a break from the box, and talk a little bit about the other part of this project, which is the inlaid panel on the lid. We'll come back to it, but we'll take a little break from the box. So I've shown you the metal hinges that I'm applying to this project. The other thing is the inlaying for the top of the box is Japanese metalworking technique. These are not my work, but these are Japanese sword guards called suba. So they're the sword guard on a Japanese samurai sword. And they were a fine art form. They were very popular certainly into the late 19th century, but hundreds of years before that. They're really miniature pieces of sculpture. I think these are probably from the Boston Museum of Fine Arts. They have one of the best collections in the country. But just to give you an idea how this is made, this is probably a brass alloy, and they've carved and inlaid different metal alloys in there, and they're sculpturally carved, and that's typically called taka zogan, or mound inlay. Zogan means inlay in Japanese, and taka is the mound. So they're raised up. There's all different types of inlay. You'll hear of nuname zogan, which is like an overlay. So you kind of cross-hatch up the surface and stick metal foil down in it, or wires. This is more of a sculptural technique. So you can, and I've really been inspired by this work, and I was able to learn from Fort Hallam at his studio in England quite a few years ago, and learn some of these basic techniques. And I'm applying it not to sword hardware, but in this case to an ornamentally turned box. Sadly, Ford unfortunately passed away a few weeks ago, which is really sad. I was really sad about it. He struggled with health problems for quite a long time. So honestly, I was in the middle of this project and working up the prototype here, or the one I brought today. But so the project's kind of dedicated to him because he was a pretty inspiring artist, very inspiring artist. So if you're interested in that process, learning more about it, Fort Hallam has published videos on YouTube going through this process. If you want to learn more about it, if you're interested, let me know. I can give you the links for that. I'll talk a little bit about it.
Are those mounds soldered on?
They're for the most part I'll get into it, but they're inlaid, so they're actually mechanically attached with almost like a dovetail, which I'll get into. So occasionally they're soldered, but most of the time it's a mechanical fit, basically. And they're different alloys because what you're seeing here is all the different colors. Well, they're different metal alloys. This work is always is made and then it's patented in a chemical bath. And the different alloys of metal, depending on what, they're copper alloys with silver, sometimes gold in them, small amounts of gold, and you'll get different colors. Like the really dark blue black is usually a copper gold alloy. The gray or tanner ones are usually a copper silver alloy, and then the red is copper, and the bright white is kind of silver. So what they would do is they use different alloys, kind of inlay them all together, and then chemically treat it at once to get the color. Whereas in the West, they would use, generally for sculpture and patination, they would use one metal and different chemicals to get different colors. So kind of a difference in the tradition, which is pretty cool. So what we'll do is I'll talk a little bit about how this process works, and then we'll swing back to the box lid and move on to that. So we'll move on to the next slide. So this is a kind of a simplified explanation for how this is done. And I'll go more detail about how I've done it. But again, Fort Hallam's videos on YouTube are the best resource I know of. So basically, what you're doing is you're first carving out a recess in the metal below the surface. So and you're raising a bit of a burr. The burr's sticking up. So you carve that out. You actually lay out a perimeter around the piece of metal you want to lay in there, and then you raise a burr around it. Then you carve that metal out with small chisels, and then you get it so the inlay piece that you want to have as a raised up shape drops down in there. And then what you do is you push the metal back down around it to trap it in there, almost like cutting a dovetail and then kind of crushing the dovetail back down. Because with metal moves. You know, you can push metal; it's malleable, so you can make it move. With wood, it would break. But here you can actually push the metal out of the way, put the piece in, push it back down, almost like setting a stone. Yeah.
Did they use gravers to do this?
Generally, they were similar to gravers. They were little chisels. I have some. I'll show you. They use tiny little hammers, tiny little chisels. Basically like a graver, but hammered. Good question. Basically chased. Yep. So you'd have put your inlay in. This is a flush-mounted inlay that this picture is showing. But the raised one is the same thing. It would just be raised up. You would basically trap the edges of it, and it's sticking up like a gemstone would be. And then it's just a rough chunk of metal, and then from that you carve that down into the raised shape. So that's simply how that's a abbreviation of how this is done. And I'll show you this step by step of how I did the unfinished part for this, which I'll get to in a moment. Next, I think. So at any rate, so let me switch over to the camera. If we could. So this is the other box that's on the PowerPoint is sold. So I wasn't able to bring it. So I made another one at Plumier, which I brought here. It's the same process, same wood. It's elongated. Okay, I used an elliptical chuck on the machine to elongate that puffy square shape. Same thing, basically the same thing. And this one is only real different. This is silver, and I carved out the top so you can actually see the wood underneath. But at any rate, what I wanted to do was put a metal inlay in the top, like a little panel, that would be where my design would go. And if we switch back to the PowerPoint, there it is. So that's the rough metal blank as it's fit into the top of the wood. If anyone knows a really good way to do that, let me know. It was a bit of a pain. This is a burl wood. I think it's red Molly eucalyptus wood. The grain is very, very convoluted in it. It was definitely a challenge to carve out for this particular one. So basically you have your metal plate that you want to inlay the metal shape into. Here I'm making a little koi fish design. So you get your metal panel first, you can see that, and then you have the koi fish, the little koi fish design, and that's bent to match sort of the curvature of that metal boss or that metal plate there, and it's dovetailed. So I filed an angle, I think about a 10-degree angle on it to act like a dovetail. You can do that by hand. I actually have a filing machine, die filing machine, where you can actually set the table to the angle you want and then run it around. It's used in the die making industry before modern technology like electrical discharge machining, but real handy for this to cut out, to dovetail the metal. You certainly do it by hand with a file too, but I felt like the filing machine did a good job of holding a consistent angle. So you can switch back to the camera. I can show you, wanted to get it done. I wanted to get this partially finished, at least for this talk. I really wanted to get the whole thing done, but afraid it didn't happen. But this is the kind of sort of what I was going for. This is a little piece I made quite a few years ago, and it's a little koi fish out of silver. And you can see that it's not inlaid into anything else, but there are the little koi fish spots on it. They're usually kind of an orange color, are copper, and those are inlaid into the surface of it. And the lie balls are inlaid also. So that was kind of what I was going from. This is a little test piece for a different project that I didn't really finish yet. Maybe someday. But that's what I was kind of drawing inspiration from, that earlier idea. And what I wanted to have was that koi fish kind of swimming in the corner of this shape on the surface, which would be a metal panel. So it's more or less carved out of the plate of silver, filed. That one's kind of filed, sawed, chased out. That one's not cast. This is the one for this box. It's a little bit bigger. It is in process, but if you want to come up after and look at it more closely, you can. I don't know if it's the camera does it justice, but you can see how it's still a little bit rough. I left it a little rough so you can see the kind of the process of carving it. So this is that shape I showed you before on the PowerPoint, which was a chunk of silver that's dovetailed and it's let into the surface of the metal. And there it is. And one of its fins here is a separate piece. I have another fin to do, and then I have the spots to put on. I did put the eyeballs in before I came. So that's kind of where we're going with this. Traditionally, Japanese will work in a pitch. This is a hard pine rosin pitch. It's pine rosin and pine rosin, vegetable oil, plaster dust, and like a little bit of carbon black. So you can heat it up, you can melt it, you can support work, and it hardens. It's really good for carving. I've even held stuff in like for guilloche work or rose engine work with this stuff, and it works really well. This is just in a little box, and I hold this in like a die maker's block, which is basically just a cannonball with a slot in it, and you can clamp it in there and you can turn it to all the angles you want. I just left it in there because you can show how that's done. So you heat this up with a heat gun, melt it, put your work in. This is another little kind of creature I did, I don't know, a while ago. This is steel piece and a little, I think it's a little gecko, a little lizard carved into brass. So that gives you an idea of how this is done. But this isn't laying on the surface, it's actually inlaid into the metal and raised up. So that's what that is. This is one I played around with. Get an unfinished one. Little rose engine or straight line engine fun. So that's brass inlaid into copper and then straight line engine turned. Unfinished, but give you an idea how that's done. I think I held that in a pitch block that was held on the machine. So that was some samples I brought. So actually, how to do it? I know you. Sorry. Yeah.
You got some little metal.
Yep.
You ever get any corrosion?
I'm sure you would if it got wet. If it got wet or moisture, absolutely. These are usually waxed. I'll usually heat them up with a heat gun when I'm done with them and put some microcrystalline wax on them. That helps soak into it. It'll help seal it. But absolutely, if these got into a humid environment, you definitely get galvanic corrosion or that. I think in a big way because you have silver, you have iron, you have all these similar metals. Absolutely, absolutely. So the tools used for this are these little tiny chisels, very similar to gravers they would use for engraving in the West here. Those usually have a wooden handle that's pushed, and and I do use those as well. I find that they're convenient for certain things, but the Japanese ones are just these little chisels that are hand driven, and they're just little chip carving chisels, really. This is a round, like, it's hard to see.
Closer to the light and then move forward in the light. There you go.
Okay, so this is like a little gouge. So this is a rounded one, rounded shape at the bottom. So it's a little gouge chisel. So you can actually use this to carve little, as you would wood or stone, really. But you're chip carving metals. That's a little gouge, a little rounded gouge. I brought a handful here. These, and these are probably worth looking at in person if you're interested. These are the ones you use to do the eyeballs for the fish. Go in with this one first, and that's it's just a rounded punch. It has an angle on the bottom of it. And you're driving that into the work to create a hole, and you stick a piece of wire in there. And this is like a little rivet, little cup tool, a little purling tool to make that little dome. So those are what I use for the eyeballs. And this is one of the inlaying punches that you use to go in and push that burr up or that dovetail up to make that area to put the metal into. That's a small one. And then here's a bigger one somewhere. This is a larger gouge chisel to carve the shallower curves. I think there's another, there it is. So this is another tool. Blunter, this doesn't cut, this helps push that raised metal up, raise that metal up, to put it in.
That's mild steel.
These are W1 tool steel, so you usually hand file them to shape, heat them up, harden them in water, polish them up, draw them, heat them back up to a straw color, and then hand finish them. So they're a simple carbon tool steel. They need to be harder than the metal, so they're a hardened steel.
You like those?
What?
You like those?
Yeah. The most of these I made in Fort Hallam's class. Some he supplied. He supplied blanks. We learned how to make them in his class. I've made my own for quite a few of them, but yeah, I have. There were blanks available for sale. Sometimes you can get blanks from Japan, and then make your own out of it. But I filed them out of solid steel. I've forged them. They're not hard to make if you're used to working with tool steels. So some basics. Better off looking at these in person. But these are an idea of the tools you'd use to do that. And little tiny hammers. I didn't bring them, but they're teeny little hammer on like a bamboo, almost skewer, really small, to take some light cuts. So I want to switch back to the thing. Let's move on to the next slide. So, okay, so that's where I want the fish to be, over there in the corner, swimming around. So what I'll do here is I will start making this sort of perimeter around it, scribe a little bit of it, and I'll actually carve out a little groove, and then I'll push that up. And then I'll go a little bit more, basically digging a little trench around where that needs to go, and then pushing up a burr, going around to the next part, pushing up a burr, and so on, until you get this trough that the thing just sits into lightly on the surface. And you can see here I laid out where it's going to go, and here I'm kind of halfway through working it up. But it's metal, so the nice thing is you can, if you're careful, you can kind of push things back. You can move it around a little bit. Whereas if you're doing this in wood, you chip the wood out, kind of screwed. So here I've gone through the 4 steps here, positioned it, worked my way through the perimeter. So now the little inlay will just snap. It'll just sort of sit there. It's not set yet, but the perimeter's established. And then over here you can see we're cutting out the waste. So what we want to do is carve that shape down below the surface to make that recess. So a good way to do that is to just cut a grid pattern basically in it, kind of scoring a grid pattern. Really looks like a chocolate bar, with those different divisions on it. But if you cut all those grooves to the same depth, then all you have to do is carve all the waste out till you clean that up till all those cut marks are gone. That you do with a series of the flat chisels and the rounded ones to carve all that out. And then hopefully then the little fish will set down in there, and you have this raised area of metal to capture it. And then that's what you do. You actually, once you get it to fit in there, you push that metal around and it hooks it in, and then you can smooth it out around there. So then it's trapped, and it looks like it's really just sitting on the surface when it's actually slightly below surface. Then it's a carving project. Then it's just files, those chisels, gravers, whatever you need to get the shape. And that one's in process, but you can see closer to the finished one here. So this is the sort of the other element I brought to this project with the Japanese inlay. Now that's this secondary project, but for the box I did in Plumier, I went with a much more simple thing. I went with just three little, I call it like 3 stones is kind of what I call this design. Simple shape. The fish is a lot of work, more sculptural, but this I went with something simpler. So in this case, it's a larger piece, and this is Makumagane, which is a Japanese wood grain metal, which is a layer of brass and copper, almost like grain of wood. Little piece I had laying around. I wanted to make it look like a stone that had been worn, and you can see the different layers in it. So I went with that. And then this one is I think they call this a marriage of metals, where you have, this is actually soldered together out of 2 pieces of silver and a piece of copper, again, to look like a stone. I think that's a piece of copper there. And these are just very simple shapes that are carved out and inlaid in. You can see that in this picture. You can see the pitch block with that in it. And you can see where I've carved out the opening for the big stone to go, and I'll do the other 2. And so that's what I did for Plumier. And this piece was textured, which makes a nice effect, and then patinated. So this was a copper silver alloy, which the Japanese call shibuichi, and that goes kind of a gray black almost. And yeah, so that's the little panel I did for this. The box is featured in the top. And so we got that far. So now we'll probably switch back to Plumier, back to woodworking, which is why we're all here. So enough metalworking. So I've established the bottom of the box. That's done. That fits the hinge. And so now I want to do is cut the bottom of the lid to fit the top of that. So I'm cutting the bottom of the wooden lid to fit down in there. Now, this is something I really wanted to play with. This is an amplitude adjuster. I think Rich mentioned them earlier, but first time I'd used one. I think this may be a prototype for the Lindo engine. I believe it is. I'm not sure. But it's really cool because you can actually change the amplitude of the rosette mechanically by moving this slide here. You're actually moving the pivot point. So you can change that amplitude, which might look great at a large size, and you can almost keep the same proportions of the shape at a smaller size. This is something I was learning and playing with. So I was able to use this to dial in that wooden shape pretty much perfectly to match the metal case. Still had to file it a little, but got me closer using the end mill. So basically you see the wooden block in the chuck, end mill here in the drilling frame, cutting on the side of it. And then the amplitude adjuster is here. And by adjusting the slide, you adjust the pivot point, and you can change the proportions that you get with the rosette, which is, I thought this was a lot of fun, really, really fun. Then you can dial it right in. So that's what I did next. And here I am cutting that shape. That's what's going to stick down into that metal shelf. And then the metal shelf fits. Yay. There it is. Over there. You can see it in place. So worked out pretty well. And then again, using the amplitude adjuster, which really gives you a lot of versatility. Otherwise, you need a different rosette for every proportion you wanted to make. Where this really came in handy, we'll get to that in a minute. But so then I reversed it and I cut the top profile of the box. So what I did is I did the lid, and you saw the lid before. You had that boss sticking out. And then I was able to hold that in the 4-jaw chuck. It was a little tricky to get this timed. I struggled with this to get that shape I just made timed with the shape on the front. That was difficult, and this thing had another problem, but I actually had to redo that part. There was a wormhole in it. So I kind of wanted to. I liked it. I wanted to kind of go with it, but I don't know with that. And then this wasn't timed right. I don't know. I ended up doing this twice, but I don't know. It worked out. So then what I did is I set up the curvilinear on the made lathe, but to face it, the profile. So I put the template here, and I've cut the curve on the face of the box lid, again with the puffy square 4-lobed rosette. And then kind of the cool part, where the amplitude adjuster was really handy, was that little panel I made, that little, the little inlaid panel, that wasn't even going to come close. If I ran the Rose engine with the normal rosette, that thing would have looked like an asterisk, I think, or like a 4-pointed star. It would have been compressed that far. So with the amplitude adjuster, I was able to get pretty close. I was able to adjust it so that the proportions were very close to that little metal panel. See how that has the same proportions as the outer shell of the box. So really handy to use that. Needed some file work, little carving to get it to fit, but I was able to rough out a lot of the material with the end mill on the Rose engine, which was pretty good. Still needs some file work. I found these Riffler files really handy for that. Again, this wood grain, I haven't really worked with burl wood. It was difficult. I struggled with that a lot. Files seem to be about the best option. If anybody has any ideas, let me know. So that's cutting the inlay for the top, for the little panel. Move on to the next slide. And there it is. That's kind of, after it's inset, it's carved in. I think for this one, what I decided to do, I think this is the second one I did on this. The other one I wasn't happy with. So I ended up holding it in basically just made an arbor. This I held this in the machine, and then I just had a screw holding it on to the front top, because this is held on with a screw from the back. So there's already a hole in it. And then I would be able to dial in this surface and then the top. Again, some file work to get it to fit. But that worked out pretty well. It was fun to carve it. Again, this was kind of a combined carving and ornamental turning project. So that was pretty much there at that point. Let's see. Oh yeah, I forgot. I made a little. So the way this worked, basically, the wooden lid portion, that metal inlay had a nut basically that I made soldered to the back of it. So I machine screw would go up from the inside, hold it on, and then the lid itself would be held on with 4 little screws into the brass. But I made a little detail out of black wood, a little guy. Again, using the amplitude adjuster to keep the proportions. It was just almost like a little decorative element, little panel. I think the thing was 5/8 square, a small little thing. And that's what I'm doing there. I cut it with cutting frame and then went around with the end mill. Had fun with that amplitude adjuster. So, and then I cut out then I had to lay out where I was going to cut the box out. And I tried, this is actually a diamond drag tool I tried. It's sometimes used, I think, in straight line engine turning. It's actually just a diamond that gets burnished on the surface. It doesn't rotate. I tried it. I put it in the machine, and I basically just ran the Rose engine around by hand to give me a scribe line. It was interesting. I don't know. I don't know if it was a good idea or not. It helped. But that way I had a profile to cut to. So I cut out the shape with the jeweler's saw. That's a diamond drag tool. It's useful on metal for decorative work. It was fun trying that. I hadn't used one of those before. You can see here I have the screw holes the locations are laid out. Well, so here's the thing more or less done. The one thing I'm new at, I'm struggling with is how to best finish this stuff. I use the gunstock oil here. and I struggled with it. So I'm open to other suggestions. The blackwood doesn't absorb the oil very well. The roll worked great, but it took a lot of coats and light coats of the oil to get a nice finish. But I did use gunstock oil on the wood, and I did struggle with that. The metal inlay I put wax on that, microcrystalline wax, which is a really good preservative. And I decided to leave the brass hinge portion just there. I could have lacquered it, but I wanted it to kind of age naturally, which it has been doing. But here you can see all the parts. You can see the box, you can see the lid with the hole in it, you can see the frame with the little button, and the metal inlay piece that has a stem on it, which goes in that hole, and then bolt goes in the back of that, and then the little blackwood detail. I believe that has a threaded, that little wire in there is silver, and there's a nut on the back of that. So that's the whole thing, ready for assembly. Next slide. And there it is, kind of done. You can see the little panels there, the little blackwood panel, little silver detail in the middle. And that's actually just glued into the blackwood, and it's threaded on the back. It's just a little piece of wire, and there's a nut on the inside holding it in place. This box has a push button and a spring-loaded hinge. So when you push it, it pops open. And you can see the little detail from when I'm turning in the bottom. You can see some close-ups of the inlaying. But so from a woodworking point of view and combining it with metal, I use machine screws here. You can see the 4 screws holding it together, and then the 4 screws holding the lid on. So that's pretty much it for this. I think there's a video of it. Hopefully that will work. I think the next one is the video. Let's see if it works. Any idea? The next slide button, or so this is a little video of it operating.
How much time do you have in making it?
I have no idea. Too much. A lot. It was hard because this was the first time doing this. It was a lot of work, but it was good because I enjoyed. I've done some of this box hinge making stuff before. This was a chance to do more and get better at it. I don't know. It was most of my Plumier internship, whatever many weeks that was. I think it was 6, 8 weeks, something like that. Probably about that much time. A lot of time, but trying to perfect it. I really enjoyed this project and want to get better at it. So I don't know any other way to try to operate the video, or yeah. Yeah.
Explain how the spring pins work.
Absolutely. If we'll try to get see on the video.
Would you like to go back to the frame? If you go back to the frame, you go.
Should I go back one slide? Well, the way this works, if you push the button, the lid pops open. What's actually happening is the spring is actually a torsion bar. So it's actually twisted in there. It's actually a round piece of wire, that's spring wire, that's filed, roughly rectangular. And then it is twisted, and then one end is pinned into the one end of the knuckle on the box. The other end's pinned into the top end knuckle on the lid. Remember I said this has an even number of knuckles because the spring has to be attached to one end to the lid, one end to the bottom. So basically you have this torsion bar that goes between the lid and the box, and it's pinned in with wedges on the end. So it's completely hidden, so you really wouldn't see it. There's no spring pushing, there's no spring inside that you can see. So the hinge pin itself is the spring. So it's a pretty neat way to do it. It's done on English card cases and pill cases. And that was, wanted to try that. That's why I made these long shapes. So I don't have that complete here, but I can show you partially how that works. Any luck with the video?
So, I've reloaded the slideshow and
Okay.
video versions and other things.
Okay.
You can allow-
So if you want to switch, I have a couple things I can show you on the camera, and then that's probably about it for this talk. Let's see. Thank you. So on this is basically the same idea. I use silver this time. Gotta be brave and try using silver. And silver, sterling's harder. It's a little easier, actually easier to work with. It's easier to solder. It being hard is helpful. but you can see the hinge knuckles. This has an even number of knuckles as well. But what'll happen is this spring wire will be pinned on this knuckle itself is attached to the lid. Okay, it's soldered to the lid. The one on the end here is soldered to the box. So if I attach the spring to this side, to the top, and the bottom to there, you'll get a torsion spring, torsion bar. It'll actually pop open when you push the button. As Ernie brought up before, this was a really roundabout way to do this. It was easier to make the wood first. I tried that with the second box. I said, that was a lot of work using the amplitude adjuster to get the shape right and filing it. So this time I just cut the this bezel area with the end mill while this is still in the machine. Same thing with the lid. Cut that boss. Whatever I got, whatever it was, didn't matter. Then I just fabricated the frame. Basically bent a piece of scored and bent one half, wrapped it around there, bent the other half, soldered it. So that was a little more direct way to do it. Use a little bit thicker material, but I'm experimenting here. I don't know what I'm doing. So that seemed to work pretty well. And here you can see the hinge. I did it the same way. I had that sort of bearer tube in first. This one needs a little misalignment, but I'll clean that up. But what? What is it? Yeah, exactly what it is. It's music wire, piano wire, and what I'll do is for the actual spring, I'll actually file this down. So I'll take maybe a third of it off but maybe a quarter of it off the top, quarter of it off the bottom. So you end up with a rectangle that's sort of rounded on the edges. Imagine taking that round wire, cutting top off, the bottom off. I'll probably do it on a surface grinder. That worked pretty well. I've done it by hand. But the surface grinder, you can get it very flat. And then that ends up being a torsion bar. I mean, it's like a strip of metal that's a spring. So, and then with the screws, again, this is sterling. So I said, I'm gonna make some screws. So what I did was, I don't want to sneeze, lose the screw. There's one of the screws. 1/16 in diameter, flathead. Yep.
You get those real too?
No, I made them. What I did is I could have turned them out of a bigger piece, but I said I don't want to waste the silver, so I did heated up a piece of silver wire, balled it up on the end with a torch real quick, and I made a heading tool plate, piece of tool steel. Basically, it's just like a blacksmith would use to make a nail or a bolt. Drilled the hole, countersunk it, hardened it, and then I just dropped in basically the wire would have a ball on the end I actually threaded it first, balled it up with the torch, dropped it in, hammered it, got my head. So that's how I made the flathead screw. Maybe you can buy them, I don't know. Probably easier to buy them, but I think that's about it for this project. And this thing has 2 posts on the bottom that I'll drill and tap for screws that hold this on, and I'll come up with some kind of a decorative screw, maybe silver, maybe I'll engine turn it or ornamentally turn. I don't know, I've kind of wanted to try something like that, so I'm open to any suggestions on that. But I think it'll be 2 screws there that'll hold that in this new shape in place. So, yeah, that's most of this thing. If we get the video working, but if not, no worries. Yeah, what's up?
The gauge, what is the gauge of the wire that you use and on the pocket?
So the spring wire here, or we can measure it. Seems like it was, get the gauge number offhand. I mean, it was, I get the micrometer out and we can measure. I think it was about 40 thousandths or so diameter, roughly. We can measure it later if you want. That is a good size. This is quite thick. This piece is probably close to 3/32 thick. The inlay for the metal, because you have to carve it out. It's fairly thick. This.
So it would be like what, 12?
Something about 12 probably. About 12 for that, because remember with that inlaying, you're actually carving it out, so you got to have some metal there. Some of it'll get squished down. I'm curious to look at it after I take it out of the pitch. It'll probably be bumpy and rough on the bottom because it actually gets pushed in a little. So I'll have to see if that's a problem. It's not a problem. That's part of the fun. So that's fairly chunky. I made that heavy so it would have enough metal to work with. But this one I made a little bit heavier. The other box, the wall was quite a bit thinner, and that is a little less forgiving. This is thick enough so I can file it down to all to match. This is a little thick. See, there's a little bit of misalignment here. I can probably bend it a little to get it to match, or I can file everything even. So the thicker wall is actually helpful. But I really like to explore these with other ornamentally turned shapes. Something a little, certainly ellipse is doable. This is another shape, but I think something like the F rosette shape would be really fun to try. I did make a lid. I might play around with that, but I think the thicker you make this, then it's more forgiving. You can actually fit it together and carve it, basically carve the metal back to match the wood if you want, if it's make it thick enough. But I mean, maybe this would be some part that could be cast in the future. Maybe it'd be worth doing that. Don't know, but this is a direct way to fit this to the wood, which I think is a little more efficient.
So that
Yeah.
green, that silver
Yeah.
frame, that started off
Mhm.
with one piece.
Yeah, it was I think two. I made that like two pieces like this and then soldered it together like that, if you imagine. I fit one half and the other half and then two. So it was two pieces. Yep.
Carve a piece of wood to bend it around and like.
Well, I bent it right around, I made this first. Yep. So I basically used what I used. I may have used pliers, I may have used a rubber mallet and a block of rubber to bend it. I forget what I used, just whatever I needed to bend it. I just bent it around the existing
So you
Easting
didn't
box.
need
I annealed it. Yeah, it was. You had to have it pretty soft, the metal, to do that. But yeah, I did it in two halves. I made one half, which was the long axis and the short axis, and then the opposite one, which was the long and the short axis. Fit them together. It's actually a pretty good way to do it. So I think making the wood box first and then doing that after is a better way to go. Because you can almost fit it to any shape. It's a matter of just taking your time and fitting each piece of metal. And I think for a more complicated shape, let's say the shape had 5 or 6 sides, you would just do, separate pieces. But that was a little more direct way to do it. So if anyone, about all I've got for this, if I brought anything else, I was going to bring that elliptical one. I did elliptical test specimen hinge, but I forgot it, unfortunately. But this one's up here to see. And I'm not sure what I'm going to do with the shape. Kind of always open to suggestions. Like I did rough cut this out just to get it open. I didn't finish any of this, but I don't know if leaving this little bump here, that kind of looks cool. That's because of the screw hole. It needs to be there. So I thought of either leaving that or maybe leaving a little bit of a fillet there. I haven't decided yet. But that's about it's about there. And I got to figure out how to do the button. I've talked to a few people about different ways to do buttons, and I'll probably do it similarly to what I did before, but that remains to be done. And then I'll probably carve out a little bit here for the button to go. And then, yeah. That's all I got, unless anybody has questions. So.